Okay, so just to let you know, I pushed back the recovery assignment due date to be Friday. So I'll give you time to finish your assignments, your homework, as well as the test recovery. And you can also ask me questions about tests as well. The recovery test is going to be on Monday. So you either choose between 7:15 or 4:30. Okay.
Are you allowed in the building at 7:15?
Yeah, I've had students come 7:15 and they haven't stopped them, so they haven't stopped them. Okay, so evaluate the integral of 2x squared sine of x cubed over 5. The first thing I'm noticing here is this looks like a U substitution problem because I don't have any rules that match up with this. Okay, but what rule do we use, right? I'm looking at this thinking, well, this looks like it matches pretty well with my sine rule. So I'm going to try to target that, right? So if I'm trying to target this rule here, what do you think my U value is going to be? What do you guys think? What could be our U value that will eventually help us move towards this rule that we're targeting?
X cubed over 5.
Yeah. So target the parentheses, right? If you see a set of parentheses, then that could be a good place to begin looking for the U value. Okay, good. And I'm hoping that the x squared will go away on its own. Okay, we'll see what happens. Okay, so we'll let U value equal to x cubed over 5. Okay, what can I use to find the derivative of x cubed over 5? Power rule, right? Maybe I can rewrite this as 1/5 x cubed just to make it a little bit easier to see my coefficient in front of my variable. Okay, so what's the derivative of 1/5 x cubed?
3/5 x squared.
Yeah, good. So bring down the 3 down in front. So du dx equals 3x squared over 5. Okay, our next step is to solve for dx. We already have a replacement for the x cubed over 5, but now we need to seek a replacement for dx. So I'm going to cross multiply, get my dx by itself. Okay, what can we do to get dx by itself? How would I move things around to get dx by itself?
Divide both sides by 3x cubed.
3x squared, right?
Oh, yeah, my bad.
Okay. All right, so dx equals all right, let's make our substitutions and see if things clean up to the point where it'll match this rule that we want to use. All right, because here's our ultimate goal here. We want to try to match with this rule here. Okay, so 2x squared stays. I'm just going to replace what I underlined initially. All right, so what do you see here? What works out nicely here? What's the important thing that needs to go away and does go away? Okay, so if we do u substitution, the only thing left, we can't have any what left over? We can't have any x's left over, right? So do you see the x's going away in this problem?
Yes.
Yeah, x squared in the numerator, x squared in the denominator, so that's clean, right? We know we can move forward because, so we're close, right? We're close to getting to that integral of sine u rule, but let's push out all the coefficients, right? So what's the combination of coefficients that we can push out in front?
10/3.
Good. So once you get that 10/3 to show up, then we're in the clear, right? We got a perfect match. That's when you know that you're in the right spot. Perfect match outside of, if you cover up the coefficient to the letter, it should match up. Okay, so now we can apply our integral rule, right? So a negative is going to show up. Cosine of u plus c, the 10/3 is going to tag along. Okay. And is this it? Is there anything else that we can do?
Plug u back in.
Yeah, let's get that, our 1/5 x cubed or x cubed over 5 back into our answer, yeah. All right, any questions here? Okay, number 8. Particle moves horizontally so that its velocity is given by the function. So here we have a function that tells us the velocity of a particle at any moment in time. So we can think of this as the particle is moving to the right, it's speeding up, slowing down, but then eventually it's going to come to a full stop, turns around, goes left for a certain number of, for 2 seconds, stops, turns around, and increases in velocity moving to the right. And the area in each of these regions tells us how far he travels in the direction that he travels in. Okay. So the areas of the regions are 3, 4, and 10, but we're going to make some adjustments. Above the x-axis will indicate as a positive, and then below we'll mark as a negative. So positive 3, negative 4, and positive 10. So first, I want to approach this like as if we're just reasoning this out. And we're not going to do any calculus notation until you feel comfortable visualizing this entire thing through. Okay. So what we do know is that this particle is only doing 3 things. It's either moving left on the x-axis, or it's moving right on the x-axis, or he's remaining motionless. So let's say he starts off at -1. So here's 0. He starts off at -1. Okay. Now, 2 seconds later, can you guys describe for me what's happening? What direction and how far does he travel? in the first 2 seconds? Okay, Tan or Vivon, what do you guys think? What does that 3 tell us?
That's
It's
the
moving
displacement.
right, so positive.
Okay, so he's gonna move, but how far does he move to the right?
3 units.
3 units, right? That's how far he travels. So where's he gonna be then? If he starts off at -1, where's he gonna be after 2 seconds? All right, he said 3 units to the right, so where's this dot gonna be?
At 2.
Okay, at 2. Okay. And then what's he gonna do in the next 2 seconds?
It would go down to -2.
Okay, 1, 2, 3, 4, okay. And then the next 4 seconds, where's he gonna be now? So he went
At
3
8.
units forwards, 4 units back, 10 units to the right, which is 8. All right, so this makes sense, right? We're told how far left, how far right to move, and we're also given where we're starting. So we know our answer is going to be 8. Okay. Does that make sense so far? Okay. So now let's put this into integral notation and see if it'll match up with what we know to be true. So we can use this formula here. Okay, so we can say final position is equal to the given position plus displacement. So I'm looking for x of 8, so I'm going to say x of 8 is equal to x of 0, because that's what's given to me, plus the integral from 0 to 8. So I'm starting at -1. I'm going to be gathering all this information here. So 3 to the right, 4 to the left, 10 to the right. I'm just going to merge all those numbers together. So 3 minus 4 plus 10. Negative 3 minus 4 is -1. -1 plus 10 is 9. So -1 plus 8 is equal to 8. Okay. Just like what we suspected. Okay. Now I want to make sure that we know that these have no relation, right? So it's a coincidence that time t equals 8. It ends up at coordinate point 8 as well. So I don't want us to think that these are always going to match, right? That's just a coincidence. Okay. All right, so I went through the first 2 pages this morning, but I'm happy to go over any types of problems that you want me to go over again. Did you have any trouble with understanding the meaning of the integral with left Riemann sum, right Riemann sum, middle, or trapezoids? average value theorem, using the calculator to find velocity, acceleration, displacement, and distance.
We did the meaning, like, how do you explain the meaning? I couldn't really get that.
The what?
The meaning, like, to describe the chart.
Oh, right here?
Yeah, that one.
Okay, so go over that. So this says that the rate at which the water flows into the tank in gallons per hour is given by a positive continuous function. I'm going to use lowercase r just to make it a little bit cleaner to make my notations. So what this is telling us is that at certain time periods, there's more water flowing in than another time period. So imagine you have a faucet that is turned on, but then at different time periods, you're either turning on full blast or you're turning it a little bit less. But the whole time, water's flowing into the tank, right? Just maybe at different rates. Okay, so that's what's telling us. So part A says, using correct units, explain the meaning of the definite integral from 2 to 11 of R of t. Okay. So if I take the antiderivative, that means I'm changing the units. So lowercase r is going to turn into uppercase R. And we have to understand what this means here. So uppercase R is no longer rate anymore. This is telling us how much water in the tank at t equals 11. Right, so what do you think R of 2 is telling us? How much water in the tank at t equals 2? So what do you think R of 11 minus R of 2, what do you think that number is going to tell us about the this condition inside the tank?
Isn't it like 9? Is it like how much water in the tank is at 9?
Well, okay, let me just use some random numbers here. Let's say it's 14 gallons per hour, 13 gallons per hour, and let's say by the 11th hour, let's say there's 100 gallons, 120 gallons.
So is it how many gallons per hour? Or like how many gallons in a certain given hour?
So R of 11 is going to tell us how much is in the tank.
Oh wait, is it a certain time period? Like how many gallons in a certain time period?
Well, if I just do R of 11, that's just going to tell us how much water is in the tank at that moment in time, or how much has been added to the tank at the 11th hour. Okay. So R of 2, let's say R of 2 ends up being only like 30 gallons. So what is that 120 minus 30? What is that, right? Let's say it ends up giving us 90 gallons. How can you phrase it in a way that can show you understand what's going on? What does that 90 gallons tell us about what's happening inside the tank?
Just there's 90 gallons.
Something with 90 gallons, that's for sure.
Is it a time period with 90 gallons?
Okay, let me just tell you what this is. So 90 gallons, what this tells us is that this is the amount of water
Oh, is it between 11 and 2?
added into the tank between the 2nd and 11th hour. Does that mean that there's 90 gallons inside the tank? That there's only 90 gallons in the tank?
No.
Right, there could be water in there already, but 90 gallons just tells us how much progress the tank gained between the 2nd and the 11th hour.
That is kind of like in a certain time period, right?
Right. It's a certain time period. But a lot of students, they want to say rate, they want to say the rate of change, but it's not that, it's actually gallons. So when you push something through integral notation, your units is going to change. So if you start off as gallons per hour, if you push it through your integration, you're basically losing a rate. So it's going to become total gallons. Okay. So that's the rest of number 2 with calculator work, with displacement, with distance. This morning I went over second fundamental theorem of calculus. I went over even and odd functions. I went over use substitution with change of variable. And then I also went over use substitution with definite integrals. Okay. Were there any ones you wanted me to walk through with you?
I think I decided doing that.
Okay, I think Tam, you've pretty much seen everything, right? Because you were here this morning.
Right.
What about Devon?
I actually can't find that sheet that I had on my test, so I'm trying to find it on my email right now.
Oh, okay. I can send you a copy of this one.
I would appreciate it. Thank you.
Let's see. Water flows through tanks. Okay, Vivon, I can't find that exact same version, but I'll send your test back to you. The problems are very similar.
I should be able to find it. I just don't have the paper copy, but it's on my phone, so I should be able to find it.
Well, I just sent you the email.
Okay, thank you.
Mm-hmm. Yeah, Vivon, looks like you had trouble with number 2, 3, and 4. But it looks like you're able to do the U substitution pretty well. And then 7 and 8, we just went over, so hopefully that'll help. So I can go over number 2 and 3.
Yeah, that would be great.
Okay, so here's the idea with number 2. Now, are you using 36 Pro or using 84, TI-84?
I'm using TI-84.
Okay, so first thing we can do is we can enter this in the calculator and look for the x-intercept. Okay, so let's enter that in. E to the square root of x minus sine x minus 5. And once you have that entered in, make sure that your mode is in radian mode. And then if you do zoom 6, it'll take you to a standard like 10 by 10 window. And we're looking to see where he changes direction. This is the velocity function. So wherever he crosses the x-axis is where he changes direction. So negative velocity to positive velocity, but it doesn't change back. So it gets close, but it doesn't change back. So there's only one change in direction. So to find that point, you're going to do second trace, and you're going to look for a 0. 0 means look for an x-intercept. Enter. And you're basically going to ask the calculator to find a point, find the x-intercept, but you're going to give it 2 boundaries. So you're going to pick a point to the left of the x-axis. So right now it's sitting to the left of it or below. Hit enter. So you're going to lock in that point so the calculator knows to start at this point and look for the x-intercept from here on forward. Now it's going to ask you for the right bound. So you're going to move to the other side of the x-axis. Hit enter. Or other side of the x-intercept, hit enter. So now the calculator knows to look between these 2 points. And we're going to make the calculator find that guess for us, find that approximation for us. So hit enter again. And it's going to locate that x-intercept for us to a very accurate location, 3.0144. I used the 36 Pro and it wasn't as accurate. So we're going to make that more accurate here. T is equal to 3.014. Okay. Do you need any help with any of the keystrokes here?
So I don't know why when I'm hitting zoom, I'm not really getting the same thing. I was trying to follow along and see if I could correct it.
Got it. So go to zoom and then go to 6. Do you see 6 here?
Yes.
Hit enter. Did it show up?
Yeah, I don't know what's happening, but it just showed me a blank screen and I entered everything you told me to until
Okay.
y equals.
So are any of your plots highlighted?
Let me check. No, I don't think so.
Okay. And you plugged it in exactly as you see it, e to the square root of x minus sine x minus 5?
Yeah, I did. Wait, oh, I think I put the -5 in the wrong place. 1 second.
Okay, try that.
Okay, yeah, I mean I have it entered fine, but it's giving me an error now.
Oh, what error does it say?
Let me enter it again. Zoom 6. Invalid dim DIM.
Are you using minus sign? You're not using this negative sign, right? You're using this sign here.
Yeah.
Okay. And then what about your mode? Is your mode in radian mode?
My mode is radian.
Okay. Let's do this. Let's clear your memory here. So do second memory, second plus.
Okay.
And then do 7, 1, 2. So 7,
7,
1, 2.
2. Oh, okay.
Okay, so at least we know everything is cleared out in case there's any random stuff that we're not able to find. Okay, so now let's try again. Y equals. Oh, are you closing your sine x?
I am.
Okay. Minus 5.
Okay, yeah, I have that.
Okay, zoom 6.
Oh yeah, that looks exactly like how it was on your screen. There
Okay,
we
good.
go.
Yeah, so anytime you run into trouble, you can do second memory 712, and that will take you, in case you enter something from previous times and you weren't able to resolve it. So, okay, so now let's look for that x-intercept. Okay, so you're going to do second trace. You're going to go to 0. Okay, second trace, go to 0.
Yeah.
Mm-hmm.
I'm gonna go because I gotta do some work at home.
Okay, all right.
Thank you.
I'll see you tomorrow. Bye. Okay, so second 0, left bound. So you're going to choose a point on one side of the x-axis, hit enter. Scroll over to a point on the other side of the x-axis, hit enter. And now it knows to look between the 2 points you gave it, and it's going to search in between for an x-intercept. How are you coming along?
Yeah, I've got it. I got that exactly.
Oh, good, good. All right, so now our reasoning is because velocity changes signs. Find Pierre's acceleration. So acceleration is the derivative of velocity. So we're going to make this go through a derivative process. So go to second mode. You're going to go back to your home screen. Okay, so now you're going to do math 8. Math 8 will take you to the derivative notation there. Okay, so d over dx. So we're going to save some time here. We're not going to enter this function. We already have it stored under y1. So I'm going to just call it from y1. I mean, I could enter this in, it just takes more time. So what we're going to do is you go to vars for variable, scroll over to y variable, and you're looking for y1, which is the function, and choose y1. So again, variable, y vars, function, y1. How does that look for you?
Yeah, I'm there.
Oh, good. So now we're asking the function to give me a derivative. We're asking the calculator to give me the derivative at a point. So it says acceleration at 3. So if I plug 3 in, rather than finding the derivative by hand and plugging in, we're just make the calculator do all the work for us. So the velocity derivative is acceleration, so 6.276. Okay, good so far?
Yeah, that makes sense.
Now, I also want to show you that you can also plug something directly into the function. So let's say you want to find the velocity at 3. Right? You're already sitting at velocity, so what you can do is you can go to vars, y-vars, call the function again. But now if you put parentheses 3, it's going to plug 3 into all the x's. So velocity is 0.09. Acceleration is 6.27. So sometimes that information is helpful because we may be asked to compare things. But this problem says, is Pierre's velocity increasing or decreasing? And this is talking about acceleration, right? You see the word velocity, but it's changing it. It's changing it by telling us that it's increasing or decreasing. So if you see the statement, then you know it's only asking for acceleration. And if my acceleration is positive, then my velocity is increasing. If my acceleration is negative, then my velocity is decreasing. But in this case, since my acceleration is positive, my velocity is increasing. The other flip side is sometimes you may see a problem that says, is the speed increasing or decreasing? And if it's asking for increasing, decreasing speed, then we compare the signs. And because velocity and acceleration have opposite signs, this problem with this, the answer to this would be decreasing speed. Because velocity and acceleration have opposite signs. Okay, does that distinction make sense? They're so similar, but I want to see if you understand that distinction.
That makes sense. Didn't you have like a chart on your website also for this?
I did. I think I may have put it in first semester though. I don't know if I have it in the second semester. But yes, I do have that chart. Maybe you can find it real quick. Yeah, I have it at the bottom of this fall summary sheet. I'll go ahead and put that link.
Yeah, thanks. I remember like using it and that like helped me a lot.
Mm-hmm. So I'll send this to you here. Yeah, I don't know if this is the same chart you're talking about, but Okay, I'm screen sharing now. And it's at the bottom of the first page, and I have it down here. I don't know if I can highlight my page here. Do you see where I'm scrolling right here? So increasing, decreasing speed, I have that information here, and I have increasing, decreasing velocity over here. So bottom of the first page, there's descriptions here. Okay,
Yeah,
so
thank you.
want to make sure, do you know how to type in the calculator for displacement and distance?
Yeah, I do actually.
Okay, so math 9, you know how to do that. Okay, good. And then another thing I noticed is it looks like you had some trouble with second theorem, number 3 and number 4. Second theorem and even odd functions.
Yeah, I think more specifically 4. 3,
Okay.
feel like I'm better with now.
Okay, all right, number 4 here. Let's go over number 4. Okay, so number 4. It says the region from 3 to 6 is -2. The region from -6 to 0 is 9. Find the region from -6 to 3 if the function is odd. So let's do the odd scenario first. Okay. Now, I split this into 2 steps. The first step is you want to sketch the shorter interval. So you see how 3 to 6 covers a shorter interval than -6 to 0?
Right.
Okay, so I want to start with the smaller interval, not the smaller value, just the smaller interval. Okay, so here's my graph. I'm going to create a situation where I see from 3 to 6. I'll just create that 3 to 6, and that means I'm going to be creating a similar notation on the other side. Okay, so from 3 to 6, my region is -2. So that's going to go below the x-axis. Now, it's an odd function, so do you know what we can do with this information?
I think I forgot.
Something about the other side. There's going to be something that we can put on the other side. Do you want to give it a guess?
Oh, would we put 2 on the other
Yep,
side, like flip
that's
the
right.
signs?
That's right. If it's even, you would make it -2 because you would make it a mirror image. But odd, you're going to create equal but opposite. Okay. Now, so you do the smaller interval, you fill the other side. Now you can move on to the larger interval. The larger interval tells us from -6 to 0, we want the area to be 9. But something we've got to be careful about is a lot of students want to do this. They want to overlap this whole thing and call it 9. But just know that this is already finished. Okay, we're not going to add anything to these regions. The only thing we're going to fill in the missing regions. So if this full region must add up to be 9, and I already have 2 here, what's going to have to be the missing space?
Would it be a -7, or would it still be +7?
It'll be +7, right? Because I need these 2 to total to be 9.
Oh, right, yeah.
So if this is 7, what can I say about this side?
That's a -7.
That's right, because it's odd function. So now we can answer the question. what is the region total from -6 to 3? So we just total the values that we see in that region. 2 plus 7 minus 7 is 2. So we can say the integral from -6 to 3 of our function is 2. Okay, does that make sense?
Yeah, it does.
Okay, let me show you what even looks like. Let's say we have the same scenario. From 3 to 6 is still -2. But it's an even function now, so what adjustment can we make?
So the sign would stay the same on the other side.
Yeah. And let's say we're also told the same information, that the region is going to total to be 9. So what can we fill out?
Oh, positive 11.
Good. How about this side?
That would also be positive 11.
Good. Even, right? So we're creating some mirror image.
Okay. Yeah, this is making a lot more sense now.
So now, if I want to find the integral from -6 to 3, just going to add up those regions. Right, 22 minus 2, 20. Okay. Any questions?
No, I'm feeling a lot better with this now.
Okay. So I would encourage you to practice going through your test again and, fill out the parts that you didn't think you got, and then you can use that to help you when you take your retake. Well, yeah, well, actually, you're going to be sending that to me because you're going to be doing corrections on your test. So, but I think this will help because this is all very similar stuff. All right, I'll probably have another help session Friday morning and afternoon. If you have any other questions as you're trying to finish up on your assignment.
Yeah, that sounds good. Thank you very much.
Yeah, no problem. I will see you guys tomorrow.
All right. Thank you again.
Yeah, bye.